Howdy, sports fans. Today we're going to talk about deductive reasoning, and that's going to close us out for the rest of the unit. We're all about that deductive reasoning. The inductive reasoning is good stuff. The ability to say, I'm seeing a pattern, you give me a claim, let's go ahead and prove it. I love it. It's good stuff. But in geometry, and as well as a lot of other places, especially in like law, I say that proofs are a way to make you guys into the best lawyers possible. You have to say, let's use some previously used and proven facts to make this happen. So, ladies and gents, as per usual, write all this down, and then we'll get this party started. So, deductive reasoning is using laws, facts, and previously proven truths to justify a claim. Okay? So, all of this stuff is basically using information that someone else has already says it's true. Okay? Like in a court of law, they use a lot of laws. Those are already ones we can use. Or other court decisions. Those are used as well. Okay? We're going to look at two main pieces, which are known as the law of detachment and the law of syllogism. The detachment is if you prove P to be Q, then Q is also true. To make this a little bit easier, I want you to remember that it's just some sort of P implies Q. There's only two parts. Okay, there's some sort of cause and effect that's going to happen. Okay, and the direction of the arrow matters. So we're not talking about biconditionals like what we talked about last time. This is saying this happens, then something else happens. So then we're going to go with syllogism. Syllogism is a train of logic. Sometimes we call that the transitive property. Okay, so if we have some P happens, that gives us Q. Q happens, that gives us some different R. So then we could say the P implies R, okay? Sometimes you might see this triple dots, which just means therefore. A good example of this is like, hey, if I do my chores, then I get my allowance. If I get my allowance, then I could go to get a free milkshake because you purchased a combo meal. Making references to the last one, okay? So this is generally a train. This is going to be 3+ parts. Now, the one thing I'm going to say about today, between the law of detachment and the law of syllogism, don't overthink this, okay? Keep it very service level, okay? It's not trying to confuse you, okay? So let's go ahead and try to think of some examples. So the best one is like, if you study, then you get good grades. So if you study, boom, that's the first part, then you get good grades. Okay? There's some sort of cause and effect. There's a P and then a Q. Cool? So detachment, first part, implies second part. Syllogism is that train of logic. This is what you guys do a lot in your heads. This is where you string everything together and hope that the ends justify the means. So if you study, then you get good grades. If you get good grades, you get to move on the next class. Alrighty. So, ladies and gentlemen, boys and girls, if you study, that's the first part. Then you get good grades. If you get good grades, that's the connector. Then you get to move on to the next class. The idea is you go to some P to Q. That Q gives a different R. Okay? And so we could therefore say, okay, if I study, I get to move on to the next class. Helps if I get my letters right. Cool? So that is a basic idea of the difference between detachment and syllogism. It's really just a base of how many parts there are. Okay? So let's go ahead and make sure, though, we're good with inductive reasoning versus deductive reasoning before we get too crazy. Okay? So let's go ahead and double check. Inductives is patterns, observations. Deductive is rules. Okay? So let's take a look at, so students at Olivia's high school must have a B average to participate in sports. Olivia's got a B average, so then she says she can participate in sports. So is that an observation or is it a rule? Well, to me, the idea is that must have a B average, so that's a rule. So I'm going to say that that is deductive reasoning. Now, again, don't overthink of this, because some of you might be thinking, well, what if there's like, it's like an implied rule, it's not an actual rule? I'm going to go back to the must. Don't overthink it. All right, the next one. Holly notices that every Saturday her neighbor mows the lawn. Okay, so I'm going to go back to notices. That notices sounds like something that you notice, like a pattern, not that's like a rule. Okay, so I'm going to call this inductive to make sure that that works. Cool? So inductive, based on patterns, observations, conjectures. Deductive, rules. Okay? Alrighty, ladies and gents, let's now test those conclusions based on what they've given us and say, hey, is this rule by detachment, or is this rule, or is this invalid with, excuse me. Try that one more time. Is that true because of detachment or syllogism, or is it invalid and therefore we don't need a rule? So, given. The idea of given is they're like, here's the scenario. You don't have to second guess it. This is what they give you. So a number is divisible by 4, then that number is also divisible by 2. So 12 is divisible by 4. Okay? The conclusion or the conjecture that someone's trying to tell you is that 12 is divisible by 2. So, obviously, we have a lot of stuff going over here. Okay? We're saying here is my P, then this is my Q. Okay? If it's divisible by 4, it's also divisible by 2. Then this is kind of like my example. 12 is divisible by 4. That is also divisible by 2. Well, that we all know is actually true. So I'm going to call that valid. And the reason why it's valid is the law of detachment. And it's not syllogism because I'm not trying to string all this stuff together to make the beginning and the end work together. Okay? I'm saying one part is true, so the other part is true. Okay? This part is true, so this must be true. That's detachment. That's not stringing it together like syllogism. And I want to really drive that in because some people look at this and are like, well, this goes to this, and this goes to that. So I could see where you'd want to say syllogism, but because this part is not all trying to bring it together to make it a full circle, detachment. All right. So Ava stays up late. She'll be tired the next day. So statement, reason. So I'm looking at possible detachment here, like once again for my rationale. So Ava is tired. Ava stayed up late. Let's pause. Let's go back to this claim right here. Is there another reason why Ava could be tired? Sure. She got a random marathon. That'd be a really good reason that she's tired. Okay? It's not that she always stayed up late. Okay? So this one is invalid. It's invalid because we can find a counterexample. So that's why we're going to say that this is not a true statement. Alrighty, so now let's go ahead. We've done some detachment here. Let's really dive into some syllogism here with the same sort of idea. For 5 and 6, let's see if we can make this a true statement based on what they have. So if it's a right angle, then it measures up to 90. If it measures up to 90, then it's complementary. That sounds like we are trying to make this connector. The connector often has the same words in there. Okay? And I'm trying to connect this part at the front, a right triangle, to complementary. Now, this is true on a side note because there's only 180 degrees in a triangle. So if one angle is 90, then the other two have to add up to 90. So this is just a true statement all around. Okay? But because we're trying to connect the front and the last statement, that is syllogism. So if I go this way, if it's a right Excuse me, I had that backwards. I was thinking of the next one. Let's go backwards here. So if they're complementary, okay, then it's a right triangle. Well, remember, triangle right there, then it's complementary. It's a right triangle, okay? So the idea is that 2 of those have to add up to 90, and clearly 3 of them can't, okay? So then this is true. And then going backwards, which is the way I first wanted to do it, so we'll go this way, it's also true, or it's also valid. So both of those are indeed valid. All right, let's give an idea of when syllogism is not valid. So this is going to be, I know it says law of detachment and law of syllogism. I'm just going to jump into this. As you can see from my diagram, that it's definitely going to be syllogism because I have 3 parts, not just 2, okay? But let's check this out. We do have the connector, so it says with the allowance, okay? So the allowance is the connector, and we're trying to justify connecting the first and the last. So if she finishes her chores, she gets an allowance. If she gets an allowance, she gets to buy a new CD. So is this going to be true? Boom, boom. Now, that is indeed true. I could say that chores can give us CDs. I can say that's true. But is that going to say that every chore gives you a CD? No, because what if you wanted to buy clothes or food? Anything like that. So this is not valid. Okay? So the difference between these two is that up here when we're talking about triangles, that was 100% true, backwards, forwards. We would love to say that when we make that string of logic, we can make that a biconditional. Okay? This one is not true because we can find that counterexample to when it is false. Okay? So that's going to be still our main thing to do when we talk about claims, logic, either inductive or deductive. But from here on out, we're really going to be in deductive land because we're going to start doing proofs. So, deductive reasoning, super important, using laws, facts, and previously proven truths to prove a claim. And then you have detachment, which is going to be one that we'll use a lot, and then syllogism, trying to train it all together. So, have a great day, ladies and gentlemen. We'll see you next time.